Welcome to UMath. Who do we have here today? Well, it is our Lego Bart Simpson, and as you can see, one of my students at some point has taken off the right leg of poor Bart. So I've got a riddle for you. What do you call a one-legged Bart Simpson? Slow. Bye, Bart. All right. The last class we talked about that we've um, gotten into trigonometry, which is geometry involving triangles or triangle measures. So we're going to continue in trigonometry here in something that is called sine. We're going to do 3 different lessons related to that. And at this point, I'm sure some of you might be asking, why do we have to learn this, Mr. Unger? Trigonometry and some of these lessons we're going through right now are actually very relevant in a number of different occupations. Who uses trigonometry? Astronomers, navigators, surveyors, and it's also very important in the study of light, sound, and electricity. So it's very relevant in our world. So that's why we study it. So today we'll start with sine. We're going to be doing sine, cosine, and tangent over the next 3 lessons. So for lesson 151, we're focusing on sine today, which basically deals with ratios between the sides of triangles, and so will the next 2 lessons. So sine. There are 2 ways to figure out the sine of a particular angle in a right triangle. Remember we said this is for right triangles. The first way is with a formula. If they give you a triangle and they tell you what the lengths of the sides are, then you use the sine formula. And the formula is right here. The sine, or for short, they say SIN, angle symbol, and then you have to say the letter, whichever one they're talking about, whether it's A or B. You'd put that here. Is equal to the opposite leg length divided by or over the hypotenuse length. Now, you got to know terminology for this. We have talked about hypotenuse already, and we said it is the longest side in a right triangle. It's directly across from the right angle. And then we talked about the other sides being legs. Now we're going to be very specific what type of leg it is, and that will depend upon which angle we're talking about. So in this case, we are going to find, as our example, the sine of angle A. So in order to do that, we do have to know what these terms mean. Opposite, I want you to think of across. Okay? So for angle A, the side that is right across from it is this side right here, where the 3 is. We already know hypotenuse. Hypotenuse is the long side. This term adjacent, think of beside or next to. So for angle A, the adjacent leg would be this one right here. It's right next to the A. And it can't be this one because we know that's the hypotenuse. Okay? So once again, for angle A, the angle that's right across, or the side that's right across, is called the opposite leg. The one right beside it is called the adjacent leg. So now we can do what we need to do for this question to solve what the sine is for angle A. So as you look at the formula here, we write down the sine of angle, and in this case we no longer put a question mark, we actually put the letter A because that's what we're being asked to do, equals the opposite leg length and we'll just write opposite leg, shorten it a little bit, over the hypotenuse. So this is the formula I'd like you to write for each question. It'll look like this. So now we just plug in numbers. For angle A, the opposite leg will be on top. So the sine of angle A, opposite leg, we said is 3. It's the one that's across. Over the hypotenuse. Hypotenuse we know is the long side. It's a 5. We don't even use the adjacent leg to figure out sine. In subsequent lessons, we will be using the adjacent leg, but for sine, it will not come up. So now we just figure this out. Now sine, the way they always do it, the official way, is to give it as a decimal to 3 decimal places, or to the thousandth. So we know that this one's not that tough. We don't have to divide it because we know it does go over 10. 6 over 10, which equals 0.6. 6 is in the 10th spot. But because they officially want it being to 3 decimal places, we simply add zeros. And then it's done. If we came up with an answer such as it was 1 over 3, we would know it would be 0.3 repeated, and the 3's would go on forever. So you would just round that, and that last 3 would not round up to a 4, and then you'd stop there. So it's always supposed to go to the thousandths, or 3 decimal places, for sine. Now, we do not put any units after it. In all the formulas we've been doing so far in geometry, whether it's area or perimeter or volume, we've always put some sort of units here, either units or units squared or units cubed. When we do sine, we will not put any units. So this is your final answer for it. So let's do a second example for the same triangle, but we will now find the sine of angle B. So we use the same formula, except this changes. So I'm just going to go right over this here, change it into a B. So the sine of angle B, it's still opposite over hypotenuse. So maybe I'll do this in a different color so as not to confuse. So opposite leg over hypotenuse, here's angle B. Opposite, remember we said, is the side that's right across from it. So across from B is the 4. So it's 4. And its hypotenuse, we've already said the hypotenuse is 5. So it's 4 over 5. And that converted to a decimal would be 0.8. And we have to make sure it goes to the thousandths. And we don't put any units after it. So that's it. So that would be the sine of angle B. So that's how you do those types of questions, to find sine using a formula only if they give you the lengths of all 3 sides. Now there's a second way to do it, much, much easier, which you guys are going to be relieved about. And that is using a chart instead of a formula. So the way it works is actually quite simple. If they don't give you the lengths of the sides of the triangle, you don't have to use the formula, you use this chart. They will give you the angle measure instead. So they'll say how many degrees it is. In which case, all you have to do is use this chart in your book. Let's make sure that's, try to focus up here. Okay. That's not bad. So you'll see in this column here, this is the sine column. Next lesson we're going to be talking about cosine, or cos for short. And then the next lesson we'll talk about tangent, or tan for short. But this is the one we need to focus on today. So if I said find the sine of 11 degrees. So they tell you the angle, you go down to 11 degrees and just go over, and it's 0.191. And that's it. That's all you have to do. Now remember to make sure you add the zeros. The chart here is not very good by not including the zeros before. But other than that, that's all you need to do. So finding sine using the chart, as long as they give you the degrees of the angle, is way easier than doing the formula, but you're going to have to do both for today's lesson, which is lesson 151. And in lesson 151, any questions to cross off would be on page 357 in sharpening skills. You may cross off numbers 1, 2, 3, 4, 5, 6, and on page 358, in the chart, you may cross off numbers 13, 14, and 15. You may also cross off 17 and 19, and that's it.
That was easy.